Problem solving using superposition theorem. Superposition theorem states that in any linear network containing two or more sources, the response in any element is equal to the algebraic sum of responses caused by individual sources acting alone while other sources are non-operative. That is superposition theorem. So our question is to find the current flowing through 3 ohm resistor using superposition theorem. And the basic requirement of a superposition theorem is that the circuit should be linear. So for a superposition theorem, the first basic requirement is the circuit should be linear. That means this is the characteristics of a linear circuit. This is voltage and current. This is V1, I1. This is V2. This is I2. So if V1 by I1 equal to R1 and V2 by I2 is equal to R2. If R1 and R2 are equal, then we can say that the circuit is linear. So for explaining the superposition theorem, the circuit should be linear. So here we have only resistors, so that we can say that the circuit is linear. And the second requirement is it should consist of two or more sources. The circuit should consist of two or more sources. Here we have a voltage source and a current source. So here we can apply the superposition theorem. So now we have to find the current through 3 ohm resistor. The first step is we have to remove the 5 ampere source. Then find the current flowing through 3 ohm resistor. Then remove the 20 volt source. Then find the current flowing through 3 ohm resistor. Finally, add the current flowing through 3 ohm resistor with the 5 ampere source only plus the current flowing through 3 ohm resistor using 20 volt source. So our first step is to, so here we can see that here we have 5 ohm resistor, 3 ohm resistor and 10 ohm resistor. So our first step is to remove 5 ampere source. That means if it is a current source, removal of a current source means the circuit is, that side is open circuited. So the circuit will be like this. So this will be the circuit. The current source is open circuited. That means there is no current flowing through 10 ohm resistor. So we can avoid that element. So the circuit can be redrawn as (3 ohm, 5 ohm, 20 volt source. So thus we can redraw the circuit. Here we can see that here we have two resistors, 5 ohm resistor and 3 ohm resistor. Both are connected in series. So the current flowing through the circuit will be I. The current, total current flowing through the circuit will be I. Total current I is equal to current from the source 20 volt source passes through 5 ohm resistor and 3 ohm resistor. That means both are connected in series. So the total current I is equal to current flowing through 5 ohm resistor is equal to current flowing through 3 ohm resistor is equal to total voltage divided by total resistance is equal to 2.5 ampere. Total current is the same for the current through 3 ohm resistor, 5 ohm resistor and 3 ohm resistor. So it is equal to, total current is equal to voltage by resistance by Ohm's law, 20 by 5 plus 3 is equal to 2.5 ampere. And second step is remove 20 volt source. Remove 20 volt source. So we are removing the 20 volt source. If we are removing 20 volt source or a voltage source, we are short circuiting that terminal. So the circuit will be like this. Here 5 ampere source is there. Total 5 ampere current flows through 10 ohm resistor and is divided into 3 ohm resistor branch and 5 ohm resistor branch. The total current 5 ampere passes through 10 ohm resistor. So the current here is 5 ampere. It is divided into 3 ohm resistor and 5 ohm resistor. Our aim is to find current flowing through 3 ohm resistor. In both the cases, current direction is downward. So current flowing through 3 ohm resistor is equal to, here we have to apply current divider rule. What is current divider rule? If we have two resistors in a circuit, R1 and R2, this is our total current, this is I1, here it is I2. So the current flowing through R1 is equal to total current into resistance of the next branch divided by total resistance. And for finding the current I2, the equation is total current into resistance of the next branch divided by total resistance. This is current divider rule. So according to this rule, I3 ohm is equal to total current is 5 ampere into resistance of the next branch divided by total resistance. 5 into 5 divided by 5 plus 3 is equal to 3.125 ampere. Now, according to superposition theorem, the current flowing through 3 ohm resistor is equal to current flowing through 3 ohm resistor with the first source is 2.5 ampere plus current flowing through the 3 ohm resistor with the second source 3.125 ampere. In both the cases, in the first case the current is flowing in the downward direction, and in the second case current is flowing in the same direction, so that we can add 2.5 and 3.125, and that is equal to 5.625 ampere. This is the first question, and we can solve the second question. This is the second question. Find the current in each resistor using superposition theorem. So here we have 10 ohm resistor, 3 ohm resistor and 5 ohm resistor, 50 volt source and 25 volt source. So first we have to remove one source and find the responses or current through 10 ohm resistor, 3 ohm resistor and 5 ohm resistor. Then remove 50 volt source, then find the current through 10 ohm resistor, 3 ohm resistor and 5 ohm resistor. So first step, we are removing 20 volt source. Remove 20 volt source, 25 volt source. So the circuit will be short circuited here because it is a voltage source. If there is a voltage source, we just short circuit the terminals of the source. So this is 5 ohm, 3 ohm, 10 ohm, 50 volt source plus minus. So this is our circuit. Now we have to find the current flowing through 10 ohm resistor, 3 ohm resistor, 5 ohm resistor. If there is only one source, this will be the current direction. The total current passes through 10 ohm resistor, then it is divided into 3 ohm resistor and 5 ohm resistor. For this, first we have to find the equivalent resistance of the circuit, and we have to find the total current from the source. Here we have a 50 volt source, so the total current from the source is to find out. So equivalent resistance is equal to, equivalent resistance is, here we can see that if you look from this side, 5 ohm and 3 ohm are connected in parallel, and it is connected in series to 10 ohm resistor, that is 10 plus 5 into 3 divided by 5 plus 3. Here 5 ohm and 3 ohm are connected in parallel and both are connected in series with the 10 ohm resistor. So we can write like this. So the equivalent resistance will be 11.9 ohm. This is our equivalent circuit. So the total current from the source is equal to total voltage divided by total resistance. That's equal to 4.2 ampere. 4.2 ampere. So here we can see that current flowing through 10 ohm resistor is equal to the total current, that is equal to 4.2 ampere. And current flowing through 3 ohm resistor is equal to, here we have to apply current divider rule, that means total current into resistance of the next branch divided by total resistance. That means current flowing through 3 ohm resistor is equal to total current into resistance of the next branch divided by total resistance. That's equal to 2.63 ampere. And current flowing through 5 ohm resistor is equal to total current into resistance of the next branch divided by total resistance. That's equal to 1.58 ampere. The next step is remove 50 volt source. Remove 50 volt source, so the circuit will be like this. Here we can see that here we have only 25 volt source. So the total current from the source flows through 5 ohm resistor. Then it is divided into 10 ohm resistor and 3 ohm resistor. So our first aim is to find the total resistance of the circuit. Then find the total current from the source. That means equivalent resistance is equal to, from this side we can see that 10 ohm and 3 ohm are connected in parallel and both are connected in series with the 5 ohm resistor. That means 5 plus 10 into 3 divided by 10 plus 3. That's equal to 7.31 ohm. So the total current I total is equal to total voltage divided by total resistance is equal to 3.42 ampere. 3.42 ampere. So this is our total current from the source, that is this is 3.42 ampere, here it is 4.2 ampere, here it is 3.42 ampere. And now we can see that the total current flows through 5 ohm resistor. So the total current flows through 5 ohm resistor, so current through 5 ohm resistor is 3.42 ampere. And current flowing through 3 ohm resistor is equal to, current flowing through 3 ohm resistor is, here we have to apply current divider rule. That means total current into resistance of the next branch divided by total resistance. That's equal to, current through 3 ohm resistor is equal to 2.63 ampere. 2.63 ampere. Then current through 10 ohm resistor. Current through 10 ohm resistor is equal to, current through 10 ohm resistor is equal to total current into resistance of the next branch divided by total resistance. It's equal to 0.79 ampere. 0.79 ampere. So here we found current through 3 ohm resistor with the only first source, and here also current through 3 ohm resistor with the second source. Likewise we found the current through 10 ohm resistor and 5 ohm resistor. So according to superposition theorem, current through 10 ohm resistor is equal to, here current through 10 ohm resistor is 4.2 ampere and this is the direction of current 4.2 ampere, 4.2. Here we can see that with the second source the direction of current is in this direction. For the first source current will be in this direction, with the second source current is in opposite direction. So 4.2 minus current through 10 ohm resistor is 0.79. And in the second case, current through 5 ohm resistor is equal to, here we can see that with the first source direction of current is in this direction, and in the second case current direction is opposite. So current through 5 ohm resistor is 1.58 and current through 5 ohm resistor is 3.42. That's equal to, it is in the opposite direction, so 3.42 minus 3.42, or we can say that 3.42 minus 1.58 ampere. And current through 3 ohm resistor is equal to, first case 2.63 and in the second case it is again 2.63, and in 3 ohm resistor current direction is same, that is 2.63 plus 2.63. So from this we can find current responses in 10 ohm resistor, 5 ohm resistor and 3 ohm resistor using superposition theorem. Thank you.